Okay. So this is the title of the talk, From Upgradable Contracts to Upgradable Applications, and hopefully it's going to be clear in a bit why it's called this way. One second. This is me, Francisco. Everybody calls me Fran around here, and I work at Zeppelin, where for the past several months we've been working. What? No, it's working. It's working. We've been working on ZeppelinOS, and well, I'm a little bit nervous. This is the first time I present, but I wanted to say that it's been such an amazing weekend, and I've been really happy to see everyone at the hackathon, hacking, building, being so good to each other, especially, and enjoying the amazing community that we have. So, in particular, as well, it was really great seeing some of the teams using ZeppelinOS, building on it and enjoying it, and that gives me a lot of confidence to come up here and talk to you and to continue building on it. So, Proxy. Oh man. Whoa. Yeah, so thanks for coming. So anyway, that's how we roll. Proxies. Facu has told you quite a bit about them at the hackathon. Hopefully you've all seen him. He's told you about some of the amazing things that we can build with them. And later tonight, Elena is going to tell you a bit more about the implementation details and some of the different things that we've explored. Myself, I'm not going to talk about proxies themselves tonight, but more about the higher level mechanisms that we're building around them. But to remind you a little bit what proxies are, basically a proxy is a contract that has a logic contract associated to it. And this is basically an address that lives on the blockchain. Whenever you want to upgrade a proxy, you basically switch the logic to a new one. And this is the basic building block on top of which the whole of ZeppelinOS is built. The thing is, this is a very low-level thing. Upgrades are, hey, proxy, take this new address and set it as your implementation. And what we wanted was to give a bit more structure around this whole thing. Because addresses are opaque. And when you see an address, you don't know what's behind it. And it's really hard to know that you're doing a correct thing. So we wanted the admin of this proxy, who decides when to upgrade and what to upgrade it to operate at a higher level. And that's the first part of the talk is going to be about the different concepts that we've explored with that objective. So the first approach that we had was a very basic approach in which the proxies for one type of contract knew a version registry which registered all the different types of logic for a contract. So essentially what this was doing was saying version 0.1.0 was this and 0.1.1 was this one other. So thanks. Essentially it was just naming the addresses that are the logic contracts, which is already a step in the right direction because now you're not working with addresses but with names and with versions. So there were some problems with this. In particular, one of the things that usually comes up when talking about upgradability is authorization. Who decides when to upgrade, what to upgrade to? Excuse me. I always wondered if the noises went on. So the way an upgrade works in this system is each proxy has an admin associated to it, and the admin has to say, hey, proxy, upgrade yourself to version 0.5. And then the proxy goes to the version registry, obtains the correct logic contract, and sets it as its own logic contract. And the same thing for this other proxy, but the admin potentially could be a different one. So we weren't too happy with that because it could lead to, inconsistent authorization, schemes and people in charge of each proxy. So essentially what we did is invert the control, and notice here the inverted arrows in comparison to the previous scheme. And we inserted this new entity here, the upgrade manager. I should have warned you, this is going to be a little bit technical, but not too much. Which centralizes the authorization logic in this one place. So now you can have when admin set in this contract, and the admin of each of these proxies is going to be this same upgrade manager. So this was the second approach that we had. It was already better, but it still only deals with one type of contract. So as I said before, the version registry holds all of the versions for only one type of contract. So for example, ERC 721. Which, by the way, I think is a really good example because from the moment that the idea of non-fungible tokens arose to the spec that we have now, the spec changed a lot, actually, and projects went on mainnet with old interfaces, and now we have to do all of this thing to have backwards compatibility, and we have some limitations with the features that we can add, etc. So, and in fact, still today, there are some things that are being developed. So I think it's a really good example in that sense. So the version registry only holds the versions for one type of contract. So we said, well, why not go all over the way and oops. Oh, yeah, no, that's fine. So instead of thinking about sets of contracts of the same type, just think about like an app, and what do we think about as an app? It's just a system that is comprised of different types of contracts that are administered by the same person in the same way. So under an app, you could have an ERC 721, or you could have a TCR contract, ERC 20, etc. So in this new scheme, the app manages more proxies than before, and they are different types. So the token registry that we had before is now no longer useful because it was only versions of the same contract. And at this stage, we call this a directory. And a directory holds different versions for different types of contracts. So at this point, we started thinking about another crucial part of ZeppelinOS, which is the idea of on-chain upgradable libraries. We've been developing OpenZeppelin for quite a while now, and we want to take that on-chain and be able to put the releases on-chain so that users can upgrade to them on-chain. So we introduced the concept in this scheme to deal with that. And that was a fallback. I don't know how this works. And that was a fallback, sort of like a fallback directory for this directory, which would hold all of like the contracts that are provided by libraries instead of by the user's own applications. So, yeah. So another crucial part of ZeppelinOS and on-chain upgradable libraries that we've been thinking about is that we want every developer or group of developers to be able to propose new versions on-chain. And potentially create forks of libraries when there are contentious issues. So the scheme of versioning that we had been using before, which was mostly linear, we had OpenZeppelin 1.9 and OpenZeppelin 1.10, was no longer useful here because you would have conflicting proposals for 1.10, and then when you have forks, the versions are no longer useful. So the fallback directory introduced the concept of distributions, and you could have different distributions of the same library, but this had a bunch of problems. It became hairy really fast, and we stopped using it. So one of the problems in particular is the same problem that I mentioned before, the authorization problem. Because this is only one contract, and if you have all of the versions for all of the different distributions for all of the contracts in the system in this one contract, then you need to have all of the logic to handle all of those upgrades in this same contract. And that felt like it didn't scale very well. And also that it wasn't generic enough, because we can't predict what people will want to do, and this centralizes it in a way that isn't helpful. So we just threw that away. And this is where we introduced a concept that I find very neat and that fits really well into the system, which is the concept of packages. Packages are something that we're all familiar with. Every system has a package manager. You have, in every Linux distribution, in every programming language, you have packages. So we said, okay, let's make it packages. And the cool thing is that the directory that we had for the app now becomes a package itself. And something that I think is really cool is that the versions of your contracts are actually releases of your package. And this is quite reminiscent of something that we do all the time. When you develop for Node.js, for example, you create an npm package, and you publish it, and you modify it, bump the version, release it, etc. So when I saw that we started having familiar concepts in this, I felt that we were going in the right direction. And I started thinking, well, yeah, that's what we want to do. We want to take the common metaphors and the common workflow of a developer and make it available for blockchain applications. So having this very standard idea of packages in ZeppelinOS was a really good milestone. At this point, we still don't have on-chain libraries. So essentially, that's package dependencies. And yeah, this actually looks very good as well, because you have the same kind of entity here that you have here, and you can compose them in very interesting ways. At this point, ZeppelinOS, you may have noticed, only supports one package, which we call the standard library, because it's where you would get your standard set of contracts to use. But we have this idea that in the future, quite actually in the near future, we could support multiple packages even. But yeah. So the package concept is a very powerful abstraction because it's very generic. It's just a very simple interface which says, for this contract name and for this version, just give me the logic address, and I will do whatever I have to do with it. But it's a very slim interface, and since it's a contract that it's deployed, you can add on top of it any authorization mechanism that you want. You could have a package that is managed by one person. You could have a package that is managed by a DAO, or you could have a package that is managed by a token curated registry. I don't know. It's just a very flexible thing, and that's also something that makes me think that we're going in the right direction. As of now, for the thing that goes here, we only have OpenZeppelin, but as I said, there could be forks, so the user could choose whatever standard library they want to use. So at this point, I think I hope it becomes clear that the reason for the title of the talk, we began with a very simple building block, and we're building a set of abstractions that allow a developer to manage an app and make it upgradable. I don't know if I say this, but one of the objectives was to bring more structure to the development, to make it higher level. And these are all very high level concepts, so I think we're doing good there. Anyway, so all of this complexity that I just talked about, we don't want the user to have to deal with it, especially because it's smart contracts, and you don't want users sending functions to smart contracts and having them revert for no reason. But so what we did was we wanted to wrap all of this complexity in a high-level interface and expose that to the user. So I'm going to talk a bit about the CLI right now. The command line interface, it has several sub-commands which give the developer access to the different functionality in ZeppelinOS. And in particular now, I'm going to talk about one of the core subcommands, which is the upgrade proxy subcommand. And I'm going to show you a bit, just as I did before, what was the iterations that we went through and where we're standing now. So at first, this is what it looked like. It was actually quite a low-level interface. You just told your application to upgrade the proxy, which is a 721, at this address. And this, this just did it. By the way, this isn't this isn't really the output that you get from the tool, but it's just to show you what would happen. So yeah, when this happens, and whenever you do an action, whatever action with the command line tool, a file will be created in your project, which is a file that exists per network that saves the state of your app as it is deployed on that network. In this case, for example, it would just say that the specific proxy has been upgraded to the latest version. So what we did next is, well, we don't really, since we have all this information stored in this file, we don't really need to specify the address. So we just removed that and made it optional. But at this point, what this did was, if there was one deployment of this contract, it would upgrade it. But if there was more than one, it would force you to specify which one you want to upgrade. And in retrospect, that's sort of too simple. Like, why did we just restrict ourselves to that? So what we did next was just, okay, since I have all of this information, and actually this command line is saying, well, I want to upgrade my 721. Well, we will just upgrade all of them that you have deployed. It's all in the network file. And this is actually what this command is saying. Just upgrade all of my 721. So the natural consequence is just, okay, I want to upgrade all of my application. And then we added this flag there, which just upgrades all that you have deployed. So, sorry, yeah. Yeah, so at that point, this is what it is at the tool now. This was the development that we did next. As you can see, it's a very simple rename. We just changed it from upgrade proxy to upgrade. But what's interesting about this, and what we realized, is that proxies are just an implementation detail. You know, we're working with applications, and we're working with instances of contracts. So the command now reflects that. I just want to upgrade my application. You know, I don't care that there's proxies behind that. So yeah, I don't know how long that was, but that was the talk. Thank you very much. This is what has been... Thanks. This is what has been going on in Zeppelin for the past several months now. It's all been happening indoors, but all in the open. It's all in our GitHub repositories, and we think it's time to throw it out to the community, see what you build, see what problems you run into, what bugs we have to fix, and what ideas you have, most importantly. At the hackathon, we had some really good ideas from some of the participants. So anyway, this is it. This is us telling you about what we've done and asking for your feedback and your ideas. So these are the GitHub repositories where we've been where we'll continue working for now. This is the library which holds the smart contracts of all that I've described in the first half of the talk. And this is the command line interface. I encourage you to go there and, I don't know, look at that, contribute, post issues, and contribute pull requests as well. And if you want more information, these are our websites. We have some really good docs that some of the team have built, especially introductory material. And yeah, this is my contact info, or just reach out to me here. Thanks.